Hi, my name is Howard Wilson. I'm a senior moderator on Grand Design's Technical, the Owners Forum. Those familiar with the forum may know me as Howson. This video is about the Furrion battery monitor that Grand Design installed for a few years in the Transcend, Imagine, and Reflection model lines. The topics we'll discuss in this video is why have a battery monitor, how is it wired in a Grand Design RV. We'll talk about the controls and displays, how to calibrate the battery monitor. Then I'll work through a demonstration with a model, and finally just a real quick overview of Victron's battery monitors, which I think are pretty cool. The original presentation this video is based on was an owner-to-owner seminar I gave at the 2023 National Rally, thus the reason for this t-shirt. The Furrion battery monitor is no longer being installed by Grand Design in the Imagine, Reflection, or Transcend lines. A lot of work went into the presentation, so the hope is this video will reach those owners who weren't at the rally. Note that for time's sake, I'll quickly step through the topics, since the assumption is the viewer can pause and/or replay the sections as needed. If there's questions, and you're a Grand Design RV owner, feel free to ask on the forum at gdrvowners.com. The purpose and goal of this video is to educate owners on why Grand Design installed the monitor and how the accuracy of the monitor is dependent on a proper calibration. One more quick note before we get started. I am not a Grand Design employee, and I do not represent Grand Design in any way, shape, or form. I'm an owner just like you. I don't have any specific government or industry electrical certifications or anything like that. So you should consider this video, this presentation, as a discussion around the campfire, without the fire obviously, between owners. So if you modify or do anything in your RV on the basis of what you see in this video, it's on you if anything goes wrong. If you have any questions, double check with your dealer, Grand Design customer service, a certified RV technician, licensed electrician, blah, 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 blah. That's all the lawyer stuff here. I think you get it. I'm doing my best here to present the information as best that I know it. Make sure you understand before you do anything in your RV, okay? Why have a battery monitor in an RV? Well, the answer is that the Furrion battery monitor is essentially a fuel gauge. Just like in your vehicle, the needle tells you how much fuel is in your tank. The display on the Furrion tells you how much power is in your battery. The amount of power in the battery can be shown as a percentage, which is shown on this slide. It can show the fuel level represented by a voltage level. We'll discuss interpreting the voltage reading in more detail, and especially in the demonstration section of this presentation. The fuel level left in the battery can also be displayed as the number of amp hours that are left in the battery. We'll dive more into amp hours in more detail in a moment. A battery monitor can also be used as a fuel flow meter. Now, what I mean by that is what's shown here on the slide is a fuel flow meter in an aircraft. It shows how much fuel is flowing through an engine, which is critical to the pilot to keep track of what's going on. Well, on a Furrion, it has an amperage reading. So it actually is tracking how much is going out or into the battery. So before we get into how it's wired, a quick overview of the demonstrator. What I really want you to concentrate on right now is on the right-hand side here with the battery, the shunt, the display, and the data cable. Later in the presentation, we'll talk about the converter and the stuff that's on the left-hand side of the demonstrator. This graphic was snipped from the Furrion battery monitor's owner's manual. We'll start up on the top left side at the battery. Notice the negative connection of the battery is connected to the B- connection on the Furrion shunt. On the demonstrator, that's the point that I'm referencing. And that is the point on the shunt that is being referenced in the diagram. Notice how the black wire comes off the battery and goes to the B- connection on the shunt. Next, we have the P minus connection on the shunt, which is everything else, every load in the RV that has a 12 volt connection, everything. And the reason for this is so that everything that goes to or from the battery flows through the shunt. This is a close-up of the shunt. Again, notice how on the B minus side, there's only one connection. And on the P minus, there's, in this case, two, but there could be even more or multiples, depending on how you have it wired. Why the Furrion can act as a voltage meter is because, as you can see, there's a positive wire going from the shunt that connects to the battery positive. There's also a positive line going in the diagram and pointing to the battery, and those are all the positive connections in the RV. The data cable is literally just a data cable that connects the shunt to the display. The shunt is where all the electricity flows through. The display is where we can interface with what's going on in the shunt in a way that we understand. Now let's look at the Furrion's controls and the display. The first thing to notice on the display is the battery symbol, and notice the stripes that are inside that little battery. That is another way of representing the percentage of charge on the battery. Note that the accuracy of those stripes is going to depend on the calibration, which we'll talk about here soon. As the battery discharges, those stripes slowly go away. Press the V button to display the current battery voltage level. A resting voltage is the most accurate state of charge in the battery. Why a, quote, resting voltage? According to batteryuniversity.com, to get accurate readings, the battery needs to rest in the open circuit state for at least 4 hours. Resting means no loads and no charging for 4 hours. No one waits 4 hours to get an accurate resting voltage. And in reality, you'd have to actually physically disconnect the P plus side of the shunt in order to completely isolate the battery from any minor draws in the camper. And you're just not going to do all that. So when we talk about resting voltage, when we go through the demonstration and the calibration, it's going to be the best that we can do. You'll see more about this resting voltage and the effect of a charge and a load on the battery voltage during the demonstration. On this slide, we're going to talk about those symbols that show which way power is flowing and the percentage representation. Obviously, to get the percentage shown on the screen, you press the button that has the percentage on it. As far as which way power is flowing, that's these little triangles. If it's pointing down with the minus symbol, that means power is flowing out of the battery and into the RV or being consumed by the RV. If there's an up arrow with a little plus symbol, that means power is flowing into the battery or it's being charged. Don't forget that the percentage displayed is a calculated figure. It might not be right if the battery monitor is not calibrated correctly. And again, we'll discuss more about calibration here soon. On this slide, you can see the little arrow pointing up with the plus symbol. Of course, as we learned in the last slide, this means that power is flowing into the battery or the battery is being charged. But the main point of this slide is to talk about amp hours. The maximum amp hours displayed are entered by you, the operator, during the calibration process. If the entry by the operator is wrong, this display and the percentage display as well will be inaccurate. And also note that the tiny 6 amp hours shown on this slide is because of the small motorcycle battery that I'm using in the demonstrator. Typical RV batteries have 100 amp hours and even more. So some of you may be wondering, well, what's an amp hour? The total amps the battery should be able to provide in a given time frame are known as the amp hours. Again, the small motorcycle battery that I'm using should be able to run at about 6 amps for 1 hour, or 3 amps for 2 hours, or 1.5 amps for 4 hours until it's completely exhausted. Hopefully you understand the math there. The point of this slide is to show that the voltage, the percentage, and the amp hours are all showing the same thing, just in a different value. The things you have to remember when you're looking at these values is that the most accurate measurement is the battery voltage. And this is only when the battery is in its rest state, as we talked about earlier. It's also important to know at this point that the numbers for the amp hours that I punched into the Furrion is a guesstimate, because the actual value for the small motorcycle battery is not known. Remember, the number of amp hours for your battery is absolutely going to be different than what I used for this motorcycle battery. So is that guesstimate of 6 amp hours accurate? We'll find out in the demonstration. Remember that the percentage and the amp hour displays are useful, but only if the battery monitor is calibrated accurately. And don't forget that that little battery ribbon across the top of the display is also dependent on the calibration. One final point before we leave this slide. A battery's amp hour capacity will decrease with age, so recalibration of the battery monitor every year or two is suggested. Last slide in the control and display section. Remember that the battery monitor is also a fuel flow meter. The other half of the A/AH button is the A button, or amps, which shows how much fuel, amperage, is flowing into or out of the battery. On this slide, the display is showing the load is pulling almost a full amp from the battery. Note the negative symbol in the little down arrow. And the 0.8 obviously is close to 1. This is useful information to determine how much power a 12-volt component in the trailer is consuming from the battery. Want to know how much amperage a fan uses? Write down the baseline shown in the display. Usually something is consuming some 12-volt power from the battery. It's usually never 0. And then turn on the fan and simply do the math to calculate the difference. So let me show you how all these buttons work. Right now, as you can see, it's in the percentage mode and the display is not backlit. So we want to change it to voltage. So I press the V button. Nothing happens. Really annoying. So I press the AAH button. For some reason, it comes to life. The backlight lights up. And now when I press the V, it shows the voltage. Right now, it's at 12.34 volts. And you can see by the ribbon up top that it should be 100%. Well, if we press the percentage button, you'll see that yes, indeed, it is at 100%. We press the AAH button. What comes up is the amperage. Remember, that's like the fuel flow meter. And right now, the only thing that's hooked up to the battery is the shunt. So it's pulling a very, very small amount of power out of the battery. We click it again, it stays on A. Click it once again, it goes to amp hour, and you can see that 6. Again, that's what's programmed in for this little tiny motorcycle battery that I'm using in this demonstrator. The first thing that we need to do in order to accurately calibrate the Furrion monitor is to know the specifications for the battery or batteries that are in your RV. What I'm going to do in this particular example is I'm going to use an Interstate 24M 12-volt deep cycle battery. This is a fairly typical battery that a dealer will install in an RV when it's sold. So researching online, I found the following specifications for the Interstate 24M battery. Voltage is fairly self-explanatory. Notice it has a state of charge, and it also has a thing called the depth of discharge. Really, the only difference between state of charge and depth of discharge is the same as saying is the glass half empty or half full. It's really no different. Specific gravity is determined using a tool called a hydrometer. That topic is outside the scope of this presentation and is not something you do on an AGM or a lithium battery anyway, so we're going to ignore that particular column. What I want to emphasize is that the voltage that is shown on this chart is the resting voltage. Next, we're trying to figure out the amp hours of the Interstate battery. Now, when I was actually giving this presentation at the National Rally, a very clever individual in the audience pointed out that, hey, isn't it right on the label of the battery? And with much embarrassment, I realized, yep, she's right. Yes, I'm talking about you, Deanna. So I went through, because I didn't notice that, I went through all kinds of hoops trying to figure out what the amp hour capacity was for this Interstate battery. And it's all written here on this slide, which you can go through and read. The bottom line is that Interstate determined the amp hour capacity based on a constant drain over a 20-hour period, and what they found, it is about 70 to 75 amps. Okay, so now that we know the battery's voltage level at 100% state of charge, and now we know the amp hour capacity, let's program the Furrion. What I'm showing here are the directions from Furrion on how to prepare the battery for prior to calibrating the battery monitor. And it literally states right in the instructions to discharge your battery down to 0%. Now, it doesn't actually say 0%. It says don't go below 10.5. But using this interstate battery as an example, if we get down below 11.9 volts, we have discharged the battery down to 0%. I could go on for at length here, quoting numerous sources stating that taking a lead acid battery below 50% will definitely impact the cycle life of the battery. In other words, how many times you can charge or discharge it. So taking theoretically a brand new battery and taking it down to 0%, which will damage it, to me makes no sense at all. So I won't belabor the point. The information is right up here on the screen of what Furrion says, but I am going to propose a different process for calibrating your monitor. And just a reminder, I'm an owner just like you. This is my opinion. Feel free to follow Furrion's instructions if that's what you deem more appropriate. So forgive the redundancy, but the top of this slide shows Furrion's process and what I do not recommend doing. The bottom here is how I suggest that you do it. Since we know that the Interstate 24M at 100% state of charge, that the resting voltage is 12.75 volts, we'll go ahead and charge up the battery to its full potential. When you see it sitting at 12.75 volts when it's resting, go ahead and set the battery monitor to 100%. How to set the monitor to 100% is actually pretty simple. You press the percentage button to make sure that the display shows percentage, and then press and hold the button for 3 seconds. If you're intent on doing it the Furrion way, and you want to set it to 0%, again, make sure that the display shows percent, and then press and hold the V button for 3 seconds. Notice also on where it shows 0% that the little battery display has no stripes. So now we're going to calibrate the amp hour in the Furrion battery monitor. Again, I don't think Furrion's process is optimal by any stretch. I'll spare pontificating about the whole subject again. My thought process is laid out here on this slide. What I suggest, the way that you do this, is now that we know, in this case, the 24M battery's amp hour capacity is 77, just enter that in. And then over time, as you use your Furrion battery monitor, using the chart that shows the voltage level versus the percentage versus the amp hour, look at the settings on your Furrion battery monitor and see if what it is telling you reflects what's on the chart. If it doesn't, you're probably going to have to recalibrate your Furrion battery monitor. Calibrating the monitor is simple. Press the AH button until the display shows the monitor's current amp hour setting. Press and hold that AH button for 3 seconds to enter the setting mode. The display will be flashing. Press the V, the left arrow, to decrease the current amp hour setting in the battery monitor. Press the percentage, the right arrow, to increase the amp hour setting. And then press the AH button again to set the value. I'll give you a demonstration of that here next. So we want to set the percentage value at 100%. First thing we need to do is switch over to percent, and then hold the percentage button down for 3 seconds, and it sets it to 100%. Now it was already there, so I really didn't show you anything. So let's go ahead and set it to 0%. We hold down the V button for 3 seconds, and it's at 0%. And notice again all the stripes disappeared from the battery symbol up there. Now let's set it back to 100%. So hold, it's in percentage, so we just hold down the percentage button for 3 seconds, and it's set to 100%. Now let's go ahead and set the amp hour display. what we're going to do is get it into the amp hour display. Then we're going to hold the AH button down for 3 seconds, and then the display will start flashing. If we want to decrease the setting, we would press the V button over here, and you can see it goes down. If we want to increase it, we press the right arrow. So in this case, we want to set it to 77. Now it's set at 77. Should continue to flash. I press the AH button again. And now it is set to 77. Since there's only 6 in the battery, it's showing that it's almost completely exhausted. So I just learned something that I did not realize as I was doing this video. If you set the percentage first, which in this case we set it to 100%, or we set the, I don't know if I set the amp hour first or the percentage, but either way, if you change the amp hour after setting the percentage, which is what I just went through, I changed this and I increased it to, I'll just go to 12 just to show you, or I'll just go to 17, doesn't matter. Now look at the percentage, which it went down to 35.3. It's not at 100%. So if this was actually the amp hour rating, 17, I need to reset the percentage to 100%. Now it will be correct. So the first thing I'd like to do is reacquaint you with the demonstrator so that you understand what's going on and what these parts and pieces are. This is a little battery tender junior. It is acting like the converter in your RV. A converter, of course, being the device that takes shore power to convert 120 volt AC into 12 volt DC. That power is used to charge your battery and then also to power devices within your RV. Well, I'm using this battery tender for the same purpose here in the demonstrator. So making our way across from right to left, of course, by now you're very familiar with the battery. And we've talked about the shunt before in the past, so you know what that is. This, of course, is the display. This is simply the data cable that connects the shunt, that little plug right there, to the display. Over here, what I have is a small little inverter to put a load on the battery, and then it converts it back into 12 volt, which powers this little Garmin GPS. And the only purpose for this whole part is to put a load on that battery. And that connects through this green connector. All right, so now you should be familiar with the demonstrator. So right now, what's of interest is that this has been sitting unplugged for quite some time, and the voltage is sitting at 12.36. So that is literally the resting voltage of the battery at this moment. What I'm going to do now is I'm going to go ahead and plug in the battery tender junior, aka the converter, so we can see what happens to the display. Before I do that though, let's look at our fuel flow meter, which is the amperage. Right now it's next to nothing, and that is again just what the shunt is consuming, and the display measuring what's going on with the battery. It's a very, very low. You notice there's not even an arrow over here showing if it's going in or out, because it's so low it doesn't even know which way to put the arrow. Yep, there goes the voltage. Notice the little up triangle with the positive as the voltage keeps increasing. So literally what's happening right now is the battery tender junior is charging the battery. And if we go to the amp, you can see that now there is almost a little more than 3/4 of an amp that's going into the battery. Notice again the little triangle and the positive sign within that little triangle. I do not know why the display is flashing. It just is. So there's nothing wrong with your video. It's exactly what the monitor is doing right now. This has been charging now for probably about an hour, and the battery is sitting at 13.24 volts. Now that's Who knows? Is that 100%? Really don't know. Do we sit here and wait to see if it goes up, if it goes down? Well, there's actually a better way to figure out if the battery is fully charged. And that is to go over to your fuel flow meter, your amps, and see how much is actually flowing into the battery. As you can see right now, it's very, very low. That to me means that there's no more room in the end. The battery is full. So we know that it is done charging. This thing is stubborn. There we go. And that it's sitting at 13.22 volts. Now I'm going to disconnect the converter. So it's only been a few minutes since I disconnected the converter, or the battery tender junior in this case, but we're going to go ahead and press on in the demonstration. You can see right now the battery is sitting at 13.5 volts. What I'm going to do is go ahead and plug in the inverter and turn on the Garmin GPS. And what you're going to see is immediately the voltage start to drop. That is absolutely 100% normal. Whenever you put a load on a battery, it will typically start to drop. And if we look at our amps, we'll see that it's actually, see the little minus over here? It is actually pulling 3/4 of an amp out of the battery. So I said earlier in this video that if the numbers that you're seeing on your Furrion monitor don't match up with the chart that corresponds with your battery, that you may have to recalibrate your Furrion monitor. Well, how does that look like for real? Well, this is an attempt to show you an example of when a recalibration would be required. So first I ran the little GPS for 1 hour, and the Furrion monitor showed that it had consumed about, 0.64 amp hours. That's the 6 minus 5.363. And then that equates to about an 89.4% left in the battery, and that the voltage was sitting at 12.44 volts. Well, does that match up with what we expected? Well, here's a chart that shows the expected full charge voltage of the battery at 100% and with 6 amp hours. And over here on the right of the slide, those are the results that we just saw on the monitor. What's strange is if you look across by the percentage and the amp hour, we expect to be up in the 90% range. So the voltage should be around 12.5, but yet we saw 12.44. So is that 6 amp hour value, remember that was a guesstimate on my part for this little motorcycle battery, is that valid? Not sure. So let's rerun the test, but this time let's run it for 3 hours. And note during this test, as the slide shows, the charger was disconnected. In this slide, we have to take a minute to absorb this and work through it. First look here where the load was disconnected after 180 minutes. The voltage was 11.82. Remember, there was a load on the battery, so the voltage dropped. We let it sit for a while, and the resting voltage came up to 12.16. Now, when you look at 12.16 with a 73.6% state of charge with 4.417 amp hours left in the battery, you take that all across, the percentage and the amp hours, we should be up around 12.32, but yet the resting voltage is 12.16. Most likely the amp hour value that we put into the Furrion monitor is wrong. The battery can't actually supply that for that length of time. So I won't bore you with how I came up with the new numbers, but I did a bunch of math, and I figured out that around 2.84 is probably the value that I want to punch into the Furrion. So I didn't actually run the 3-hour test, but based on the expected test results, you can see this is kind of the same chart. If I came up with that 12.16 volts again, I would have consumed around 1.42 amp hours, and the percentage would have been around 50, and that equates, sure enough, right to about in the chart where we expect it. So as you can see, the earlier estimate of 6 amp hours was wildly off, and all I had to do was to make sure that the Furrion monitor was accurately showing me a percentage and the number of amp hours left in this little battery. I had to reprogram it with 2.84 amp hours. So last but not least, a plug for my favorite gear, Victron. The BMV 712 and the Smart Shunt are much more sophisticated pieces of tech than the Furrion monitor. I won't go into all the details. That's not the point of this video. The really great thing that I want to contrast with the Furrion is that you can monitor what's going on in your RV on your phone, as you'll see in this next video. What you're seeing is me actually starting Victron Connect on my phone, and I'm sitting right here at my desk, and that's because my trailer is connected to the internet. If I was close to my trailer, I could just connect via Bluetooth. But this connects. I select my BMV 712 and it comes up, and by now you should know what the voltage and the current and the power, the consumed amp hours, time remaining. Right now it's dash because it'll go forever based on the load, but these things are constantly dynamically updated by the intelligence in these devices, and I just find it really cool tech. So if you made it this far, thanks for watching. Remember that the takeaways from this presentation is that the primary purpose of the monitor in your RV is for battery power management. Gives you an inside view of what's going on. And the second takeaway, it has to be calibrated for it to be accurate. All right, if you have any questions, you know where to find me and all the other members of the community at GDRVowners.com.